It's not wanting to write, so let me just rewrite that all together. It's not liking my pen today, not sure why. Okay, so in series I have Q total is equal to Q1 is equal to Q2. So since I already found Q total, then I know that the charge on this one is equal to 96 coulombs. So this one's 96 coulombs, or microcoulombs. And this one's also 96 microcoulombs. So now I can find the voltage. That's what I want to find, the voltage across here. So let's do that. So the voltage, and let's call this one, if we call this capacitor 1, and we call this capacitor 2, and we call this capacitor 3, and we call this capacitor 4. So this combination here is actually capacitor 1, 2. And this capacitor, whoops, 1, 2. Didn't want to do it. Come on. 1, 2. And this capacitor here is 3, 4. All right, so I want to find voltage 1, 2, meaning the voltage across here. And the way I do that is I use that equation again, the one here, Q is equal to CV. So since Q is equal to CV, I can solve for V alone, and I divide both sides by C, and I get Q over C is equal to V. So that's what I'm going to use. I'm going to use Q over C. And so I end up with Q over C is equal to 96 microcoulombs over 6 microfarads. And so that is equal to 16. Oops. It's equal to 16 volts. Okay, and I can do the other one the same way. So V 3, 4 is equal to Q over C. And now Q again is 96 microcoulombs, and now my capacitance up here is 12 microfarads. So this one I have 12. Okay, so now I know 96 divided by 12 is 6. Yeah, 96 divided by 12 is going to be 8, so 8 volts. And that makes sense, right? Because 8 plus 16 equals 24, and that's the total voltage that I have. So I would expect when I go across this capacitor, I'm going to drop a certain amount of voltage, and when I go across this capacitor, I'm going to drop a certain amount of voltage, and they should add up to 24 volts. So that makes sense. So now if I want to find, if I look at my circuit, my original circuit here, I can see that here my voltage is going to be the same going into each one of these capacitors. So I have my voltage, so I'm going to use 16 volts for my voltage here. So I know there's 16 volts going through this capacitor, and there's 16 volts going through this capacitor. So since I know that, I can find the charge, since I know also the capacitance. So I'm looking for Q1 is going to equal C1 times V1. And so C1 is equal to 1 microfarad. And V1 is equal to 16 volts. And so I end up with 16 microcoulombs. So that's Q1. And that makes sense. That's the answer that we have here. And now Q2 is equal to C2 times V2. And now V2 is the same as V1, right? It's the 16 volts. The 16 volts goes through both of those capacitors. So now I have 5 microfarads times 16 volts. And so I find that is 80. So I get 80 microcoulombs. Okay, and that makes sense too, so that's the answer. And now Q3 is equal to C3 times V3. And so that's going to equal, let's see, 8 microfarads times 8 volts. So I end up with 64 microcoulombs. And Q4, last but not least, is equal to C4 times V4. And so then I have 4 microfarads times 8 volts. And so that's 32. Oops, come on. So 32 microcoulombs. So that's it for that problem. I'm also going to include a link to another problem that was solved by video, and so it's a similar type of a problem, but it might help to go through that one too.